Hi, welcome to screencast session on week 6, improving the Dijkstra's algorithm using MinHeap. If you could see that, so earlier implementation of MaxHeap, similar lines we already implemented the MinHeap. So the only property the different is the MinHeap root element is always smaller than its left and right descendants. So this is existing heapify function and create MinHeap, which is called the MinHeap property. It is satisfying the opposite property of the MaxHeap. Similar lines, every time we are trying to update the MinHeap, which is that level wise we do that, each level wise except leaf nodes. And this is whenever you are trying to delete, so one minimum element which could be the root element of the MinHeap. So then again we try to update that heapify. So this is all existing MinHeap construction. We want to use it for Dijkstra's. So earlier Dijkstra's, it used to take it that O of n square complexity, but now we can improve the complexity, so which is better than that O of n square. For that we are taking that two global variables. The first global variable is that h2v, which is one dictionary, that's called heap2 vertex, and similar lines, so v2h also we are taking. This is also empty dictionary. So why should you take a global variable is, once the global variables are taken, these variables can be used by the any of the heap function. You can check it. So anywhere you can use that h2v or v2h without sending as a parameter, so that we can reduce that parameters count whenever you are calling the function. So let's do that. The Dijkstra's algorithm as usual. We do the initialization part. So that infinity we are taking the existing Python constant of float, which is called INF. So this INF we have used at earlier one, the same one. Here visited dictionary we are taking. Initially it's empty dictionary. So then after it, we try to take a heap size. Basically it's the length of my uh, existential list which you sent as a parameter. So that it's the length of the W list. So then after it, we try to do the initializing that v2h and h2v. For this, we are using iteration v in w list of keys. We try to initialize that each of that v2h and h2v. So that v2h is, it's a dictionary. So where the v it contains the v itself. Similar way, the heap to vertex also, it contains that vertex value with two things. That's it contains that vertex v and as well as the reachable distance. So the shortest distance we don't know until it is computed with the Dijkstra's process. It's infinite initially. So then after it, the visited status of the v is also false because we don't know, still now it is not visited. So once you have done it, we start that starting vertex. So as usual, the heap to vertex, the starting vertex of this particular traversal is always we try to start it from s, which is sent as a parameter. So that's s we are taking. The reaching distance is going to be 0 because starting vertex has 0 distance, because by itself it is 0. So after that we try to call that existing creating heap. So that's the minim heap we are creating. So it takes that heap size as a parameter. So this will call that, so earlier defined min heap creation. So basically it creates that min heap, which is that vertex to heap and heap to vertex. So once this is done, let's start that Dijkstra's algorithm process where you are using iteration, whether the vertex is visited or not. If it is not visited, the minimum distance we are computing and we are updating. So for this, for you inside of it, W list of keys. So this case, we try to pick up that the next vertex which are trying to visit it and the distance of it, that could be ds, and heap size. So what is the current heap? So whenever you are trying to delete one particular vertex from the min heap, so it will return that 3 tuple value. You can check the 3 tuple value, and this is what the 3 tuple value, the node and the distance and updated heap size. Whenever the root node is deleted, the heap size is reduced by -1. So that -1 value, which is decremented value of the heap size or updated heap size, is going to be returned. So now we are taking the visited of this particular next vertex you are visiting, that making as a true, because once you have visited, that becomes true. So now we try to do that. So a two tuple value we are getting from, so W list of the particular next vertex, that's called next D. So if it is not visited, if it is not visited of V, so whatever adjacents are there for the next D, all these we are getting into this particular iteration. If the adjacent is not visited, then we try to update that H to V of V to H, so which is for the V, and it's a first tuple value. The first tuple value represents the distance. We are trying to get the minimum updating, whatever the minimum, that's called H to V, and the V to H of this particular V, the first tuple value, if the first tuple value is it the minimum one, or you can say that whatever the distance we got at, that distance plus the adjacent one distance, that's called D. So whether that existing distance is a minimum one, or via D it is a minimum, via adjacent it is minimum, whichever the minimum is there, that's going to be updated to that V vertex. Now we try to do that, the min heap updating, which is the latest update, we do that. So that's V to H. So V to H, we try to update that V to H of the V. So this particular V to H is updated, and whatever the heap size we got recently, which is updated heap size, that's what we send it. So this min update, what it will do is, once it is visited, it tries to do that next particular set of heap things available. In that again, you try to get it that deleting process. This deleting process is done. Always deleting will do that minimum distance one only. That minimum distance one, if it is not visited, make it visited true. And then we try to update whether the existing distance is minimum or via D is a minimum. So this we have done it. So let's run it. It can improve the complexity. I think delete mi is wrong. Yeah, it is minimum. Oh, sorry. I think it was defined in the line number 1. Oh, sorry. It is code runner where it is calling. Right. Let me check it. Maybe my delete method is different. Yeah, delete min. So this is what the delete min. Indentation is perfect. Yeah, for you, it's taking parameter of that heap size. The heap size we have taken. So let me run once again. Where is my delete mi? Yeah, it is manually, no? Correct. There's something wrong in this. Delete min. This is creating delete min function. Yeah, it's okay. Somewhere. Let me run this. Yeah, got it. So maybe, some kind of indentation or some issue. So here 0 to 0 reachability is 0, but if you compare the 0 to 2, it might be the 16 is the shortest distance, and similar line 0 to 6 is 35. So hope you got it. Thank you very much. Have a nice day.